Okay, so now that we have identified the two triangles that we're going to be using, what I'll do is, since this is just part 2 of the video, I just want to explain there's a different scenery that's going on. It's a different day. Currently the time is 12:34 and it's the 28th of July, and we're still dealing with the sine rule. So now what I'm going to do is just carry on here by now identifying the different parts to it. Mind you, I am in a place where people are passing by. You guys might hear trucks. I do this so that people can be awake in my videos. I like it that the students can actually hear an environment in the background so that you guys are a little bit awake. And it also applies to me as well because I'm outside. So that means, yeah, I get to experience nature while I teach, which is quite nice. So yeah, just going into it here. As I mentioned, we got our two right-angled triangles. Now we can actually identify the components that we need to actually prove our theorem, right? So for the first part, what I'm going to do is just state what you're going to be needed, right? So here we've got the side BG, right? And that is a common side between both triangles ABG as well as GBC. So that's one of the parts that you guys are going to need. So I'm going to then name BG as X, right? Because both of them have a BG. And then I will move on. It's a bit louder now. I'll then move on and then explain what else we need. So the first thing, you will need the hypotenuse of AB. You'll also need the other hypotenuse of BC. So those two hypotenuses are very important in answering or proving your theorem, right? So let us begin. So what I'm going to say is, first things first, to remember that what do we have for sine? We've got some old hens. So sine theta is equal to some old hens, so opposite over hypotenuse, correct? So what I'm going to do is now use that opposite over hypotenuse in my answering. But the two angles I'm going to refer to, the first one will be angle A, and the second one will be angle C, right? So that we can create a ratio with them, right? So basically it's your idea of creating a ratio out of those two. So I'm going to then go on to then substitute for the first triangle. I'm going to substitute in triangles A, B, G, and then I'll also want to substitute into triangles B, G, C, right? And what am I substituting here? I'm substituting the ratio, right? The ratio of sine theta being opposite over hypotenuse. So in this case, I'm going to just say sine A is equal to, my opposite side is then X. My hypotenuse in this case is AB. I'll label it as AB, right? And then on this side, I also want the same application of sine C, which is then equal to what? X over BC, right? So if I rearrange this, I can then have sine A multiplied by AB is then equal to what? It's equal to the side of X, or just X in this case. And I can also do the same thing, rearrange this formula by saying sine C multiplied by BC is equal to X. And then guess what? I now can equate the two triangles to each other, because now I have both of them have a what? An X, right? A side of X which is equal to each other. So substitution there make things equal to each other. So it's got sine A multiplied by AB is equal to sine C multiplied by BC, right? So now I can then rearrange this, right? And call these sides something else. What I'm going to do is just remove the h's there. I'm gonna rename them. So rename the side AB as the side C, small c, and rename the side BC as A, right? Small a. So in this case, what I'll just do is now substitute that into the expression. So I then have sine A multiplied. What is AB? AB is equal to small c. And then we've got sine C multiplied by what? BC. And what do we have for BC? We've got A. So all I then have to do is rearrange this formula by moving things over the bridge. What I'm going to move in the first one. Okay, that's a big truck. Very loud. So what I'm going to do is in the first one, I'm going to move this over the bridge and that over the bridge. So in this case, the rule would then say C over sine C, capital C, is then equal to what? The side A over sine A, capital A. Another thing I can do is then rearrange it in terms of this, moving the small letter C and the A over the bridge. So the second one is then me moving the small letters, so I can then say sine A remains as sine A, and then guess what I'm dividing by? By small a, right? Because that then turns into divide, and then I've got sine A remains on this side, oh sorry, sine C remains on the right side over who? Over C. And then finally that then tells us that if I've got sine A over A is equal to sine C over C, then by default the last side there, what's the last side? The last side is B, so let's just name it as B there. The whole entire side of AC is B, will then give us this then. So it will say sine B over small b. And then I've made my proof, right? Or I have then got all the points that I need, or all the remarks I want to make. So just to recap, right? With your sine rule, what you want to do is start off by creating what? Two right angled triangles. Out of any triangle, you want to create two right angled triangles. Once you have created the two right angled triangles, what are you going to do? Start substituting things, right? And the most important side is this perpendicular line here, right? The perpendicular line BG, which then you need to equate, right? Meaning you substitute the values without, I don't want you guys thinking about this, right? The small letters, don't think about them up until you get to this point here, right? So that's what I do with my students. Up until you get to the point where you've got sine A multiplied by a side, that's it based on a hypotenuse. So this is a hypotenuse. This is also another hypotenuse, right? Once you got those two hypotenuse, then you can then say substitute the values in terms of C, in terms of a C, or small c in this case, and in terms of an a small a in that case. And then you can then go on and find your rule there, right? And it doesn't matter which side you pick, because these are interchangeable, right? You can swap them around, right? Okay, so that's about it for this video. The next video is going to be then based on application, and I'll see you guys in the next one. Cheers.